Okay, so part A asks us to find S of t, which is the position function. So for this, we have to remember this relationship. Position becomes velocity if we take the derivative, and velocity becomes acceleration if we take the derivative. So if we want to go the opposite direction, the antiderivative would be integration. And your calculator can't integrate this type of integral. This is an indefinite integral. So we're going to have to plug this in and integrate it by hand. So not even any u substitution needed. The derivative of e to the t gives you e to the t. The derivative of negative 6t gives you negative 6. And then of course there could be a constant, so we need a plus c. And it says for any time, so we should have t's in our answer. That should be part A. Yes?
Can you go through like what the grading would look like? What do you need to have on there?
For this question, I suspect this would probably just be a 1 point is the answer, right or not.
Okay.
But that's my guess.
Let's go.
Okay, part B. Okay, part B wants A of t. So again, you still need to know this relationship between position, velocity, and acceleration. So if you've got velocity and you want acceleration, you need to take the derivative. The derivative of e to the t is e to the t. The derivative of a constant is 0. That's all you have to do for part B. I would guess that's probably a 1 point question too. Part C, when does the particle change direction? So what you have to know for this one is that when velocity is positive, it's going to the right. When velocity is negative, it's going to the left. So I would, this is a calculator question, so even though I can do some of that by hand, actually I guess I could probably do the whole thing by hand, but why not just graph it? I graph velocity. Velocity's negative here, so it's going to the left at these times. I guess here, because this is backwards in time, that doesn't make sense. It's going to the left and then it's going to the right. This is where it's changing direction. So I've noticed going around helping some of y'all, some of you like the table, and that's great, but oftentimes the table just has integers. Like, that's not accurate enough. You can see it somewhere between 1 and 2, but you've got to get within 3 decimal places. So instead, you could do second trace, calculate the 0. Left bound means hit enter when the cursor is somewhere to the left of the 0 you're trying to find. Right bound means move the cursor somewhere to the right of the 0 you're trying to find. And then hit enter to skip guess, and it will jump to that point for you. So this is a needed calculator skill. 1.792. At t equals 1.792.
Is that what you have to write down?
I would say you probably would get 1 point for that. And it doesn't say justify why, but I suspect that they probably want to know that. And so my guess would be the other point would be this is where velocity changes from negative to positive. What does not work is to say it changes from negative to positive. No one can assume what it is. It might be obvious to you, but what you write on paper has to stand on its own. Another common thing y'all like to say is the graph. It crosses the x-axis. Okay, what graph? You graphed the velocity. No one else knows what you graphed. Don't say that. Just say velocity. You don't have to say it. You don't have to say the velocity graph. Just say velocity changes from positive to negative. It was going left, and then it's going right. So probably a point for that too. Okay?
So you have to have that? Because it just asks, like, when, not how.
Well, see, I don't think this is a real released FRQ. Like, I know number 2 is it previously, like, real one that they put on there. So it's hard for me to say exactly how they've scored that. But there has been times where I've seen questions that, yeah, like part C, it kind of looks like it just wants the answer, but then in the scoring guide it does want a justification too. So it's hard for me to tell you what it's always going to be.
So they won't just tell us when they want a justification?
I think they try to, but I don't know. Like in one like this, like you should know why. So since that's just a quick 5 seconds to write that down, I would do it just to be safe, personally. I agree with you that it's kind of unfair to count it as a point if they don't ask for it, but I have seen that before on some FRQs. So, okay, is the particle speeding up or slowing down at t equals 1? Well, at v of 1, I'm going to use my other calculator. If I plug in 1, I get e to the first minus 6, which is negative something. So that means it's going to the left. And then a of 1, I've got a of t up here. So that would be e, which is, this is about 2.718. So this is positive. So it's the rate of change is increasing. So if this is negative and this is positive, is that speeding up or slowing down? Slowing down. Because the direction you're going makes a difference. I'm going quicker to the right, but this guy is going to the left because of his velocity. So if you're traveling left, but your rate of change is to the right, you're actually slowing down. You're going slower to the left. For v equals 2, same thing, but plug in 2. This guy is positive. This guy is positive. And when they have the same sign, it means it's going to the right, and he's going faster to the right. So increasing. Signs are the same, it's increasing. Signs are different, it's decreasing, it's slowing down. Because you got to take into account direction too. All right, and then finally, what is the total distance traveled by the particle in the first 5 seconds? So the easiest way to do that is if you integrate velocity, this is going to give you the change in position. I only care about what happens between 0 and 5. The problem is sometimes it's going to the right and sometimes it's going to the left. So what this would give me is called displacement. And that's not what it's asking for. It's asking for total distance. So whether it's going to the right or left, I want it to both be positive. And even though this is possible to do by hand, algebraically, if you look at the solutions, I think they do this by hand, and it's super long and messy. But again, why bother? This is a calculator question. You don't have to integrate any absolute value stuff. Just ask your calculator from 0 to 5. If this was velocity, then this would be the displacement, but total distance, we need to squeeze in an absolute value sign. You guys understand the difference between displacement and distance? You're okay with that?
I understand that, but I don't know, like, I don't really understand why the absolute value sign gives you distance.
Line 4.
Because displacement would be like how distance they started at
I think the easiest way to show you is with the graph. So this velocity, like since velocity is negative here, it's going to the left, right? Can correct? But if you're going to the left, don't you want that to count towards your total distance?
Oh, okay.
But see, it's if you don't have absolute value, then it's considering that to be negative. So it's taking this away from this, and that's not what you mean. Whether you're traveling to the left or traveling to the right, it should add to your total distance. And I don't know. They didn't give us any units, so I guess we just say units. They didn't give us units of any of this, but oh yeah, they did. They gave us seconds, I guess. So in part C, I'd probably go back and add seconds. Again, I don't think this is an actual real FRQ, but one common thing for a point, which you guys will see sometimes, is that if you have the units correct in all parts, you get a point, and if you didn't include the units on something, or you put the wrong units on something, then you lose one of those points. So a lot of times 1 of the 9 points does come from having your units correct. Okay, anything you'll need to speak up and say about this FRQ before we move on? Yeah.
And part D,
Uh-huh.
this is just for this type of problem.
Uh-huh.
If velocity is moving left at all,
Okay.
like period, does that mean that it's slowing down?
No.
Only if it's left. Only if the negative number is greater than the positive number. I'm saying that weird, but do you know what I mean?
If velocity and acceleration have different signs,
Uh-huh.
it's slowing down.
Okay.
Because this guy's going left because it's negative, but because acceleration's positive, it means his rate of change is increasing to the right. So he's traveling to the left, but he's traveling slower to the left because of acceleration.
Okay.
If velocity and acceleration have the same sign, whether they're both positive or both negative, then the speed's increasing. If they're both negative, it's increasing to the left. If they're both positive, it's increasing to the right.
So
But the easiest way is to just think about the signs. Signs are both the same, it's increasing speed. Signs are different, it's decreasing speed. That's all you have to consider.